remain the same. We are going to mask this particular GUI, whatever we are seeing it manually, and we will have only one click where we will start the automation. The pictures will be automatically taken. Only the PLY generation will be shown to the end customer. So all these things we have already automated. We have a POC also for that. What we have done.
Explain what you're doing.
Okay. So this particular section, whatever we are doing is matching. So here we have key point sensitivity. What I have done is, since the focal length is very low over here, I need to keep it at a very high level in order to at least get the matches for the end to end, the complete arch. And over here, what is the ratio? I have set it to 0.7. So all these parameters are predefined from AKS matrix. So there's a algorithm called AKS. So based on that we have set. And here what we are doing is, classical AKS is generally for larger portion. Means if I want to capture this area, for that one we'll go for classical AKS, which will take longer time. And what we have done is, we have kept an option called fast AKS, which is pretty fast. But what it does is, it takes the points like this, 1, 2, 1, 2, 1, 2 points, it will match, and it will start building from here. Okay. And this is the camera setting. And what is the algorithm that we are using is flannel algorithm, which is standard across all the cameras for Omnivision.
No, my point was, if it is a default high, default 0.7%, then
no, this will be,
or it will vary every time.
No, it will not vary. So what will happen is, this is specific to this camera. So once that camera comes into picture, it will have its own specification.
Then camera to camera you have to calibrate?
Yes, we will have to calibrate. So it will take around 1 or 2 days for us to calibrate the ratio for that particular camera, set it, and based on that particular setting, we are going to automate the entire process.
0.7, 0.6.
Yes.
So
that will be in our scripting, how we are going to do that.
Is it again after one scanning you have to set it?
No.
Predefined,
it is like predefined. It is only matching. So we are playing around with the software. So whatever photo has been taken is already taken. What we are trying to achieve is, based on the photo, whatever metrics that we want to build, we are just playing around with the script and getting the right composition. Means where whatever is there, the complete art should be achieved. Thank you. So here you can see the sparse triangulation dots that has got created right now. So since this is only a point where the triangulation can start. So for example, this arch is there and it has a point over here, high point, low point, and a depth point. So it is not a complete arch right now. It has only created a discrete points. So right now we are going to create a dense cloud around it. So you can create the dense cloud, make it MBE. Now I am creating a multiple.
So you got a logic such a way that it go to the only extremities, lower and higher.
Yes.
And in that plane,
yes,
look for the peaks and valleys.
Correct. So when it matches this picture and the other picture, when it matches, there will be a slight deflection of the angle. So what is the deflection? It will match, and here from this point to that point it will match, and it will check what is the ratio of height over here. Based on that, it will only create a 3D triangulated points. So right now it is creating a dense cloud. What it will does is, it will start stitching from here.
What is the pool proofing system you have used? Like, it can take a peak when you are moving up and down, right?
No. Any 2D image will generally be under a specific matrix. So any 2D image will have a specific surface area, and it will not go beyond that surface area. Whereas in 3D, you always can achieve multiple angles.
Yeah, because angular.
Here it is specific. It will only be either 90 degrees, 45 degrees or 60 degrees angle. When you do a computation, the angle is set. So once the angle is set, then it will start building on top of that.
So you keep that assumptions first, then you will start taking with reference to that point. Okay.
So this is only a cloud which has got created. This is not even the surface that has got created. So you can create the surface. Go to position reconstruction. Increase the depth to 10. Okay, so what we done over here is, we are trying to create a surface. This is the PLY generation. So any person for that matter, when we scan, we will take the pictures in trios as well. So we will not be able to get the entire complete thing. So what we do is we do a second time scanning as well. So first time scanning, I'm trying to create the depth of the surface, and also I'm trying to calibrate the ratio at which it is creating the depth. For that, I made a setting over there. So there was a depth.
So you answered my time. Foolproofing system is second time it is taking a reference.
Yes.
Then it is making sure that we are in the right path.
Yes, yes.
So that foolproofing system is there, then it will have a two data.
Correct.
Look into. If you
Yes.
failed one, it will give
It
an
will-
error to you.
Yes.
Then you can scan it once more time and match it.
Yes, yes. Right now, so whatever tooth are missing right now, I can again rescan, add it to the same picture set. Again, it will compute the matches. Again, it will build the entire arch.
Oh.
So it is as good as what Trios does is once you scan, there will be patches which is left out because it is not shown. What we are doing, achieving with